This video is part of a deeper dive series exploring more things, looking at different bullet weights through different barrel lengths of using the same load to try to find out what has the most energy, since energy hitting hard is the entire point of shooting. It's faster than throwing a rock, a whole lot easier, and gives us more distance. That's why we do it. Terminal performance on the target has way too many variables to get into what the actual projectile is going to do guaranteed every time. So the one thing we can measure for sure is muzzle energy. That's what we're doing here today. The series is meant to look at practical energy through different barrel length guns with different bullet weights to see if there really is an ideal. Why else would you have 115, 124, 147 common loads? At the time that I decided to do this, only one company had in stock the same loading, as in not HST versus Hydroshock versus Deep, all that versus critical duty versus critical defense. Only one company had multiple weights of the same load in different calibers, and that was SIG. This is in no way sponsored by SIG. I purchased this on my own. They have no idea that I'm doing this. Barrel lengths chosen were chosen in order of commonality, things that you might have at home, so this can be most relevant to you. For 45, we have a 3.8 inch from Springfield XD. We have a 5 inch, the classic and semi spec, and then we've got a 6.5 inch X-Tar EP45, which I think might shed some light on usefulness of 45 for us. Little 3.8 inch barrel. This was my second carry gun because I was a 45 guy and a 1911 guy before this. So I stayed with 45. Haven't shot this thing in years. This is an XDM compact 3.8 inch. Starting off with the 185 grain. See what kind of speeds we get. .983. I forgot how flippy this gun was. 984. 984. 980. And 988. Now onto 200 grain projectile through a 3.8 inch barrel. .852. 877. 869. 883. And 884. And now that what will be the slowest, but we'll find out if the weight makes a difference, 230 grain from the 3.8 inch barrel. 752. 780. 778. 779. And 764. And now, through the wonders of post-shooting editing, you should have the energy to show which load gave us the most energy out of this little 3.8 inch barrel. Curious if any of you guys learned anything from this. Thanks for watching.